Okay, this is linear algebra. Lecture 14. And I'm going to do the problems in homework number 7. So these are on page, well, the first group are on page 123. Let's look at number 1. So number 1 asks us to find elementary matrices. So what is elementary matrix? An elementary matrix is a matrix obtained from the n by n identity matrix. What is that? Identity matrix of any size is a matrix with one down the diagonal and zeros everywhere else. So it's a matrix obtained from the identity by applying one elementary row operation. So you have to know what are the elementary row operations. They are interchange two rows, multiply by a row by a non-zero constant, or add a multiple of one row to another row. So let's take a look at that. So in problem 1, find the matrix E1 such that an elementary matrix such that E1 applied to the matrix 1, 2, 3, 4 gives the matrix 3, 4, 1, 2. So what does it do to this matrix? It interchanges the first two rows. The first row becomes the second row. The second row becomes the first row. So if you take the identity matrix 1, 0, 0, 1, and you interchange the first and second rows, you get 0, 1, 1, 0. So this is the entry matrix E1. And you can check. So E1 times 1, 1, 3, 4, 4. So this is supposed to be E1, 1, 0, 1, 1, 0, 0, 1, 2, 2, 3, 4. Perform matrix multiplication, get exactly what you're supposed to get. So the elementary matrix E1 is this. Find the elementary matrix E2, which when you apply it to the matrix 1, 2, 3, 4, gives you the matrix 5, 10, 3, 4. Well, what is the difference between these two matrices? The second rows are the same, but the first row is multiplied by 5. So E2 is just the matrix you get when you take the elementary matrix, the identity matrix, and you multiply the top row by 5. Right? That's E2. And if you want to check, 5, 0, 0, 1 times 1, 2, 3, 4, in fact, is 5, 10, 3, 4. So the checks. E3 is the elementary matrix you get when you multiply, such that when you multiply 1, 2, 3, 4, that matrix, you get 1, 2, 4, 6. So how do you get from this matrix to this matrix? Well, you have to stare at that a little bit. You see, the first row didn't change, but if you add the first row to the second row, you get 4, 6. So E3 is what happens. You take the identity matrix and you add first row to second row. So first row doesn't change, but when you add the first and second row, you get one. That's E3. And again, you want to check 1, 0, 1, 1 times 1, 2, 3, 4. If you do multiplication, you get 1, 1, and 2. Works. So that checks. So that's problem 1. Problem 2 is to consider certain elementary matrices and find the inverses. So these are 3 by 3 elementary matrices. E1 is the matrix 1, 0, 0, 0, 0, 1, 0, 1, 0. So what is this elementary matrix? How do you get this from the identity? Well, this is the identity, the 3 by 3 identity. And you get this matrix by interchanging rows 2 and 3. So if you interchange rows 2 and 3 again, you should get back where you start. So it should be that E1 inverse is the same as E1. So that's I take 1, 0, 0, 0, 0, 1, 0, 1, 0 times 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0. If I multiply, I get 0, 0, 0, 0, 1, 0, 0, 0, 1. I get the identity. So the inverse of this matrix is itself. In the same way, if I look at E2, each elementary matrix 0, 1, 0, 1, 0, 0, 0, 0, 1. This matrix from the identity by interchanging the first 2 rows. So if I interchange a second time, I should get back to where I started. So again, 2 inverse in this should be U. E3 is the matrix 5, 0, 0, 0, 0, 1, 0, 0, 0, 1. How do I get this matrix from the identity? I multiplied the first row by 5. So if I take the matrix where I multiply the first row by a fifth, that should be the inverse. E3 inverse should be 1/5, 0, 0, 0, 1, 0, 0, 0, 1. If I take a matrix and I multiply the first row by 5, and then I multiply the first row by 1 over 5, I'm back where I started. So that's E3 inverse. What about E4? E4 is the elementary matrix 1, 0, 3, 0, 1, 0, 0, 0, 0, 1. How would I get this matrix from the identity? I would get this matrix from the identity by adding 3 times third row to the first row. So if I then subtract 3 times of the third row from the first row, I should be back where I started. So E4 inverse, I guess, 1, 0 minus 3, 0, 1, 0, 0, 0, 1. Let's check one. Check. E4 is 1, 0, 3, 0, 1, 0, 0, 0, 1. 1, 0 minus 3, 0, 1, 0, 0, 1, 1. This is 1, 0, 0, 0, 1, 0. And third column is minus 3 this. This is 0, 0, 0, 1. So this also checks. That's E3 inverse, E4 inverse, and E2 inverse versus the original matrices. Okay. 5. The next problem on the homework starts with a 3x3 matrix. A equal to 2 minus 8x 0, 1, 3, 3, 0, 8. And when we put this in reduced row echelon form, called the reduced row echelon matrix R, and we want to find an S, which is a product of elementary matrices, such that SA equals R. So we want to find S and R, SA equal R, where this is in reduced row echelon form. This is a product of elementary matrices. So the simplest way to do that is to write down matrix A and make that the left half of a matrix, where the right half is the identity. And then now put this new matrix in reduced row echelon form. So the first thing we want to do is 1 here. So I multiply the first row by a half. And leave everything else the same. And I want to get 1 there. So I don't touch the first row or second row yet. But I take the third row minus 3 times the first. 3 minus 3 is 0. Minus 3 times minus 8 is 24. 0 plus 24 is 24. 8 minus 9 is minus 1. 0 minus 3 halves. 0 minus 0 and 1. Okay. Then I want to get a 0 in these two places. So my middle row is okay. Give me a moment. I can get a 0 here by adding 8 times row 2 to row 1. So 0 plus 1 is 1, and 8 minus 8 is 0. 24 plus 3 is 27. 0 plus a half is a half. 8 plus 0 is 8, and 0 plus 0 is 0. And I can get a 0 here, subtracting 24 times the second from the third. So 0 minus 0 is 0. So 24 minus 24 is 0. Minus 1 minus 72 is minus 73. Minus 3 is minus 0. 0 minus 24, 1 minus 0. So that seems to be where we are. Let me just double check because it's easy to make this. 2 minus 8, 6, 0, 1, 3, 3, 0, 8, and then the identity. So I made a mistake away. I divide the first row by 2. I get 1 minus 4, 3, half, 0, 0, 0. And then the next 2 rows haven't changed. This is minus 4. So from this, I subtract 3 times the first row from the third. So 3 minus 3 is 0. 0 plus 12 is 12. 8 minus 12, sorry, it's minus 3 times this. Minus 9 plus 8 is minus 1. Minus 3 halves 0, 1. Okay. Then divide. Okay. So then I want to get a 0 here. So I add 4 times the second row to the first row. 0 plus 1 is 1. 4 minus 4 is 0. 12 plus 3 is 15. 0 plus a half is a half. 4 times 1 is 4, and 0. And I want to get a 0 here. So I subtract 12 times the second row. 0 minus 0, 12 minus 12, minus 1 minus 36, minus 37, minus 3 halves, 0 minus 12, 0. Okay. Then I want to get 1 here. So I divide this row by 36. I'm going to get 1, 0, 15, a half, 4, 0, 0, 1, 3, 0, 1, 0, 0, 0, 0, 1. I'm dividing by minus 36. So 3 over 36 and over 12. 12 times half is 1 over 24. Minus 12 over minus 36 is a third. And then last step is, and we get zeros here and here. So this row is 0, 0, 0, 1. 1 over 24, 1/3, 0. If I take the second row minus 3 times third, I get 0 minus 0, 1 minus 0, 3 minus 3, 1 minus 1/8, 1 minus 1, 0. And if I have 15 times the third row, if I take the first row minus 15 times the third, I get 1 minus 0, 0 minus 0, 15 minus 15. 15 over 23 is 5. 15 over 24 is 5 over 8. A half minus 5/8 is minus an eighth. 4 minus 15 over 3 is 4 minus 5 is minus 1 and 0. So this is my R, and this is my S. So it would be that this matrix, which is a collective elementary matrices, if I did the calculations right, then this times A is equal to R. So let's see if that's true. Hard to believe I do all this without making a mistake. So we'll see. I want to calculate S times A. So S times A, what was S? Minus an eighth, 1 over 24. Minus 1, 0, a third. 0, 0, 0. That doesn't look good. Has to be a row. And this times A. What was A? 2 minus 8, 6. 0, 1, 3, 3, 0, 8. So what is here? I get minus of the fourth. So that's already wrong. 1, 0, 1 minus 1, 0. Minus 3/4. This is all wrong. So I have to go back and check my work. That's the way it is. So it's important to make mistakes, and it's important when you find a mistake to try and figure out what you did wrong. So my matrix A 2 minus 8, 6, 0, 1, 3, 3, 0, 8. Then I augment it with the 3 by 3 identity, so I have this 3 by 6. So the second row and the third row haven't changed. But I divide the first row by 2, get 1 minus 3, I have 0, 0, 0. And I want to get a 0 here. Let me make sure I haven't made copying from one row next. 1 minus 3, I have 0, 0, 0, 0, 0, 1, 3, 0, 1, 0. So third row minus 2 times the first row. 3 minus 3 is 0, 0. 0 plus 12 is 12. 8 minus 9 is minus 1. 0 minus 3 halves is minus 3 halves, 0, 1. So this looks okay. Then when I get zeros here and here, so my third row, 0 and 3, 0, 1, 0. I multiply the third row by 4 and add to the first row. I get 1, 0, 15, a half, 4, 0. Okay. And then to get a 0 here, I take the third row minus 12 times the second row. 0 minus 0, 12 minus 12, minus 1 minus 36 is minus 37. It's a mistake, minus 37. Minus 3 has minus 0, 0 minus 12, 1. So that's 37. Okay. Then I want to make this a 1, so I divide this row by minus 37. So now I get complicated fractions. But maybe I can't avoid that. I multiply this row, or I feel equivalently, I divide this row by minus 37. I get 1. I get 3 over 2 times 37. So 2 times 37 is 74. So this is 3 over 74. Minus 12 over 37 is 12 over 37 and 0. Okay. And then the last step is to get those here and here. So I have 0, 0, 1, 0, 0, 1. This row is 1. Sorry, this row is 3 over 37. 12, sorry, 3 over 74. So copy my stuff down correct. 3 over 74. 12 over 37, 0. Okay. Second row minus 3 times the third, 0, 1, 0. Minus 9 over 74. 1 minus 36 over 37 is 1 over 37 and 0. And the first row minus 15 times the third row is 1 minus 0, 0 minus 0, 15 minus 15. A half minus 3 times 15, that's 45 over 74. A half is 37. So 37 minus 45 is minus 8 over 74, which is just minus 4 over 37. The minus 15 times 12 is minus 6. Minus 15 times 12 is minus 30 times 6 is minus 180 over 37. Four times 37 is 148. So 80 minus 148. This looks like it should be minus 32 over 37 and 0. So again, unlikely this is correct, but never know. We just have to check. So my S, this is May. My S is the first column is first row is minus 4 over 37 minus 32 over 7. The second row is minus 9 over 74, 1 over 37. The third row is 3 over 74, or 12 over 37. Okay, now let's see what happens when I multiply. For this first coordinate, I get minus 8 over 37 plus 8 times 32 over 37. Sorry, I get minus 8 over 37 plus 3. Again, it's all. I don't know what I did. Let me think about this for a moment. Let me go back and see where I made a mistake. So somehow, I think I see it like that. Here I had a 1. Now here I got a 0. So why was that? Excuse me 1 second. So how did I get from here to here? I wanted to get a 0 this place. So I subtracted 12 times the second row from the third. So 12 minus 12 was 0. Minus 1 minus 0. This was a 1. So then, when I want to get a 1 here, I divided by minus 37. So this was 1 minus 3 over 74, 12 over 37. And this would be minus 1 over the 37. And when I eliminated the 3 here, I multiply this row by minus 3 and add, which makes 3 over 37. And when I eliminate the 15 here, I multiply this by minus 15, and which makes plus 15 over 37. All right, so let me go back now and check my work. So here, everything was okay, except that last column was 15, 3 minus 1. 15 over 37, 3 over 37, minus 1 over 37. Now, let me try to calculate all this. First row and first column, I get minus 8 over 37 plus 0 plus 45 of 37. 45 minus 8 is 37 over 37. So that's 1. When I'm multiplying the second column, I get minus 32. I get plus 32 minus 32 over 37. I get 0. First row into the third column, I get 6 times minus 4. So that's minus 24 over 37. Minus 3 times 32, which is minus 96 over 37. And 8 15 is plus 100 over 120 over 37. That's 0. And like the second row, first column, like minus 8, 74. Sorry, I get this is minus 9/74 times 2. So it's minus 9/37 plus 9/37. Good. Second row, second column is 30/72 over 74 plus 1/37, 2 over 70, you get 1. And this row and this column, minus 54 minus 27, it's also 0. And the third row, first column, 0, 0. Plus 36, 45, minus 1. So if you check the arithmetic, I finally got it. So this is my S. This is the original matrix A, and this is the R. When you reduce this matrix, you get the identity. Oh, that's a lot of work. Okay. Good. That was problem number 5. Next, problems are on page 27. Go to 1 to 27. These are more just learning how to calculate more of these things. Use the algorithm, was this doubling of the matrix with the identity to compute the inverse. So for problem 1a, we have the matrix 3, 2, minus 8, minus 5. And I want to augment this with 0, 0, 1. Row would do this matrix. So I can divide the row by 3. I get 1, 2 thirds, 1/3, 0, minus 8 is 5, 0, 1. Then I can take, here's the first row, add 8 times the first row to the second row. 8 minus 0, 16/3 minus 5, which is 15/3, is a third. 8 thirds, 1. I want to make this a 1. Here's my first row. Multiply this row by 3. 0, 1, 1, 8, 3. And then to make this 3, I take the first row minus 2 thirds times the second. 1 minus 0, 2 thirds minus 2 thirds. 1/3 minus 2 thirds times this. It's 1/3 minus 16 thirds is minus 15 thirds is minus 5. And minus 2 thirds times 3 is minus 2. So it should be that the inverse is this matrix. So let's check. 3, 2, minus 5 times minus 5 minus 2, 8, 3. That's minus 15 plus 16, minus 6 plus 6, 40 minus 40, 16 minus 15. So that checks. And parts B and C are just the same type of problem. Same type of problem. You have to do work. And part 2 is more problems of this sort, 3 by 3 and 4 by 4. And I'm not going to do them. It's just a matter of doing the algebra very carefully And I notice even I have the solution right here on the page. So you can check your work and see what you get. And again, I encourage you, if you have questions, to come to one of the problem sets and ask me. And that's it.